Ever wondered if the symphony of your favorite band could light up your house? Sound is more than just a sensation for our ears. It's a form of energy. When you hear a sound, what you're actually perceiving are vibrations. These vibrations, or sound waves, travel through the air or other mediums and eventually reach our ears. But what if we could do more with these vibrations? What if we could harness them and convert them into something else, like electrical energy? That's a question that isn't just the stuff of science fiction. It's a topic of ongoing research in labs around the world. Think about it. Every sound, from the softest whisper to the loudest roar, contains energy. And if there's one thing we know about energy, it's that it can be converted from one form to another. So, if sound is energy, and we can convert various forms of energy into electricity, can we indeed turn sound into electricity? The idea of converting sound into electricity isn't as far-fetched as it might seem. In fact, it's a scientific principle that's been known for over a century, and it's called piezoelectricity. Piezoelectricity, derived from the Greek word piezein, which means to squeeze or press, is a phenomenon where certain materials produce an electric charge when subjected to mechanical stress. This stress could be a physical force, or in our case, the vibrational energy of sound. Now you may wonder, how does this work? Well, in a piezoelectric material, the positive and negative charges are symmetrically distributed, creating a balance. However, when mechanical stress is applied, this balance gets disturbed, causing the charges to shift and create an electric field. So, if we apply this principle to sound, the idea is that the sound waves, which are essentially pressure waves, traveling through a medium, could cause a piezoelectric material to vibrate. These vibrations would then generate mechanical stress, leading to the creation of an electric charge. But of course, we need a way to capture and convert this charge into usable electricity. And that's where devices called transducers come into play. Transducers are devices that can convert one form of energy into another. In this case, they convert the mechanical energy of sound vibrations into electrical energy. A common example of this is a microphone. In a microphone, the sound waves hit a diaphragm, which is connected to a coil of wire in a magnetic field. The vibrations of the diaphragm move the coil, generating an electric current. This current is then amplified and converted into a signal that can be recorded or broadcasted. So, fundamentally, the science of converting sound into electricity exists. Piezoelectric materials and transducers do allow us to turn the vibrational energy of sound into electrical energy. However, like all scientific principles, the challenge lies in its application. So, while the science exists, the question remains, is it feasible to generate a significant amount of electricity from sound? As promising as it sounds, turning sound into electricity isn't a straightforward process. There are numerous challenges to consider when it comes to harnessing sound as a viable source of energy. Firstly, the energy output from sound is relatively low. Sound waves, in their essence, are vibrations that travel through the air or another medium. To generate electricity, these vibrations need to be captured and converted into electrical energy. However, the energy contained in everyday sounds is often too minimal to power anything more than small, low-energy devices. Additionally, sound energy is not always readily available. Unlike other renewable energy sources like the sun or wind, which are constant and predictable, sound is sporadic and dependent on the environment. This makes it a less reliable energy source. Moreover, to produce a significant amount of electricity, you would need a constant, high-intensity sound source. This could potentially lead to noise pollution, which is another problem in itself. Despite these challenges, there are potential applications of sound-to-electricity conversion technology in specific circumstances. For instance, imagine a bustling city street or a busy factory floor. These are environments that are naturally loud and could potentially be harnessed to power small devices such as traffic lights, sensors, or communication devices. Another potential application is in the field of wearable technology. Devices such as hearing aids or fitness trackers could potentially be powered by the user's own voice or ambient noise. There is also potential in the realm of renewable energy. If we can find a way to efficiently harness the sound energy from high noise areas like airports or concert venues, we could add a new, albeit small, source of renewable energy to our mix. While the idea of powering our homes with the sounds of our daily lives remains a distant dream, the potential applications of this technology are truly exciting. It's a testament to human ingenuity and our constant quest for sustainable and innovative energy solutions. So, what have we learned about the potential of converting sound into electricity? Well, we've discovered that sound, in essence, is a form of energy, created by vibrations that move through a medium, typically air. We've delved into the science of piezoelectricity, a process where certain materials generate an electric charge in response to applied mechanical stress. This is the principle behind transducers, which can convert sound waves into electrical signals. We've also looked at the challenges in harnessing sound as an energy source. The energy density of sound is relatively low, so we'd need a lot of it to generate significant amounts of electricity. But let's not forget the potential applications of this technology. Imagine powering your devices with ambient noise or even your own voice. While we can't yet light up our homes with our favorite tunes, the science of sound to electricity conversion offers fascinating possibilities for the future. Stay tuned for more intriguing insights into the world of science.